हेलो, गुड मॉर्निंग टू ऑल। सभी को मेरा नमस्कार। टुडे इज अ स्पेशल डे फॉर अस। टुडे वी आर डूइंग द 50th एपिसोड। बिल्कुल हमारी आज हाफ सेंचुरी होने वाली है। तो इस एपिसोड में मैं बिल्कुल सभी का बहुत 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 थैंक यू बोलता हूँ, बहुत शुक्रिया बोलता हूँ। और ये जो जर्नी है ये शुरू हुआ था लगभग 2 साल पहले। हमने पहला एपिसोड किया था जून 7 को 2020 में। और ये क्यों सीरीज शुरू हो गई इसके पीछे थोड़ा सा मैं कारण भी आपको बताता हूँ। आपको मालूम है 2 साल में बिल्कुल पैंडेमिक की वजह से इनिशियली सभी स्कूल बंद हुए थे, सभी टीचर्स बच्चे घर में ही थे। तो हमारे टीम ने सोचा, आइसर ने ये सोचा कि इस बच्चों के लिए, टीचर के लिए कुछ ना कुछ करना चाहिए। हमने लगभग मार्च में लॉकडाउन शुरू हुआ था और हमने 2 महीने सोचा, कंटेंट क्रिएट किया और पहला एपिसोड जो हमने किया था 7 जून 2020। और हमें इतना रिस्पांस मिला, पहला ही एपिसोड लगभग 70,000 लोगों ने देखा। तो हमें कॉन्फिडेंस आ गया, देयर इज अ लॉट ऑफ डिमांड ऑफ साइंस एंड मैथमेटिक्स एक्टिविटी। ये टीचर ने डिमांड किया था, ये स्टूडेंट ने डिमांड किया था। तो हमने सोचा कि ये सीरीज क्यों ना जारी रखे। तो वो उस टाइम हमने सीरीज शुरू किया और आज हमने आज ये मुकाम तक पहुंच गए कि 50th एपिसोड हम कर रहे हैं, हाफ सेंचुरी आज हम कर रहे हैं। तो मैं सभी टीचर को, सभी बिल्कुल बच्चों को धन्यवाद देता हूँ, आपको थैंक यू बोलता हूँ कि हमारे पूरे एपिसोड्स में आपने हमें इतना ह्यूज रिस्पॉन्स दिया, बहुत हमें प्यार दिया, बहुत सजेशंस भी दिए। उसमें से बहुत कुछ आइडिया भी नहीं निकल आए। तो ज़्यादा से ज़्यादा जो आइडिया आपने दिए थे हमने वो इम्प्लीमेंट भी किए, डॉक्यूमेंट भी किए। सो थैंक यू वेरी मच फॉर ऑल दैट। और जैसा मैंने आपको बोल दिया था तो थोड़ा सा मैं आपको ग्लिम्स देता हूँ कि पहला एपिसोड हमने जो 7 तारीख को किया था तो यहाँ से किया था। देखिए, दिस इज अ बिल्डिंग ऑफ द आइसर पुणे, दिस इज द कैंपस ऑफ द आइसर पुणे। और ये बिल्डिंग के जो सामने इंट्रेंस में बहुत अच्छे कोट हैं, ये मैं आपको बार बार दिखाता हूँ। आइसर पुणे वेयर टुमारो साइंस बिगिंस टुडे। और इस कैंपस में जो आउटरीच सेंटर हैं, श्रीमती इंद्रानी बालन साइंस एक्टिविटी सेंटर, यहाँ से हम आपके साथ जुड़े हैं, आज भी जुड़े हैं। और ये जो फोटोग्राफ आप देख रहे हैं ना, ये पैंडेमिक से पहले हैं। यहाँ बहुत फिजिकली बच्चे आते थे, टीचर्स आते थे और उनके साथ हम साइंस एंड मैथमेटिक्स एक्टिविटी के वर्कशॉप करते थे। और अभी भी देखिए, लगभग अभी थोड़ा सा रिस्ट्रिक्शन कम हो गया कोविड-19 का, तो हमने अभी फिजिकली वर्कशॉप भी शुरू किया है। और इसका जो फॉर्म है हम डिस्क्रिप्शन बॉक्स में अभी देंगे, लेकिन यू कैन ऑल्सो रजिस्टर एंड कम फॉर द फिजिकल वर्कशॉप। और एक मैं पिक्चर आपको दिखाता हूँ। देखिए यहाँ बच्चे कितना इंजॉय करते हैं, उसकी आँख की चमक देखो, बच्चों को कितना मजा आ जाता है वर्कशॉप में। 3-3 घंटे, हाफ डे बच्चे जगह नहीं छोड़ते। जब सामने बहुत अच्छा चलता है तो बच्चों की आँख की आप चमक भी देख सकते हैं और उस टाइम उनके लिए टाइम का भी कुछ लिमिटेशन नहीं होता। 3-3, 4-4 घंटे बच्चे एक जगह पे बैठ के ऐसा साइंस एंड मैथमेटिक्स सीखते हैं। We are not only working with the student, we also work with the teachers. So this is the one of the teachers workshop. और जिनको साइंस में रुचि है, आपको टीचर में तो है, लेकिन पेरेंट के साथ भी इस टाइप के हम वर्कशॉप करते हैं। तो ये थोड़ा सा मैंने आपको आइडिया दिया कि यहाँ क्या टाइप के वर्कशॉप होते हैं। और अभी मैं आपको लगभग 2 साल पीछे लेके चलता हूँ। जो पहला जो एपिसोड हुआ था उसका मैं आपको पोस्टर दिखाता हूँ। और तारीख क्या थी? 7 जून, संडे सीरीज, उसका हमने नाम भी दिया था। और टाइमिंग देखिए, वही टाइम पे आज लगभग 2 साल के बाद हम आपके साथ जुड़े हैं। द टाइटल ऑफ द फर्स्ट एपिसोड वाज प्रेशर इन फ्लूइड। और उसके बाद जो ये सिलसिला जारी रहा। 10वां एपिसोड हमने किया था 9 अगस्त और उसका भी टाइटल क्या था? देखिए, एक्सप्लोरिंग हीट एनर्जी। और ये था 10वां हमारा एपिसोड। और उसके बाद ये सिलसिला चलता रहा। और 25th सिल्वर जुबिली एपिसोड जो हमने किया था 6 दिसंबर को किया था और उसका ये हम आपको पोस्टर दिखा रहे थे। और उसके बाद देखिए जो 30th जो एपिसोड है उसका मैं आपको पोस्टर दिखाता हूँ। ये 30th एपिसोड था देखिए, और हमने बाद में हमने नाम बदल दिया लाइव लेक्चर एंड डेमोन्स्ट्रेशन सीरीज। और वो फ्लोटिंग एंड सिंकिंग के बारे में है, बेसिकली डेंसिटी एंड बॉयंसी के बारे में था ये एपिसोड। और जो 40th एपिसोड था वो कब हुआ था? 10th October 2021। एंड व्हाट वाज द टाइटल ऑफ दैट एपिसोड? बियॉन्ड अर्थ। ये हमारा 40th एपिसोड था। और आज जो हम कर रहे हैं वो जो कर रहे हैं 50th एपिसोड। और उसके लिए वी आर वेरी वेरी लकी, हमें यम प्रकाश जैसे स्पीकर हमें मिले हैं। और यम प्रकाश जी ने बहुत लोगों को मोटिवेट किया है। मैं यम प्रकाश जी के बारे में आपके साथ थोड़ा सा बोलूँगा, लेकिन उससे पहले ये सभी जो एपिसोड्स है, जो लगभग 49 एपिसोड्स, और उसके साथ भी जो हमने MSCRT के साथ जो किया था वो 15 एपिसोड्स, ऐसे 64 एपिसोड्स की जो प्ले लिस्ट हैं हम अभी डिस्क्रिप्शन बॉक्स में डालने वाले हैं। तो आप बिल्कुल एपिसोड के बाद हमारे पूरे प्रीवियस जो एपिसोड्स हैं बिल्कुल देख सकते हैं। उसमें हमने फिजिक्स, केमिस्ट्री, बायोलॉजी, मैथमेटिक्स, अर्थ एंड क्लाइमेट साइंस, बहुत अलग अलग टॉपिक को टच किया है। और ये एपिसोड का पहला हमारा पैटर्न भी क्या था? लगभग 45 मिनट्स हम डेमोन्स्ट्रेशन देते थे, और लास्ट जो 20-25 मिनट्स जो हमें मिलते थे, हम एक फैकल्टी को, ऐसा पुणे के फैकल्टी को बुलाते थे और बच्चों के साथ इंटरेक्शन, बच्चों क्वेश्चन पूछते थे प्रीवियस एपिसोड्स में, और उसका आंसर फैकल्टी उनको देते थे। तो ये हमारा पैटर्न था लगभग 25 एपिसोड तक। और बाद में हमने डायरेक्ट फैकल्टी को यहाँ बुला दिया, और उसने भी आपके साथ बहुत मतलब एपिसोड्स में इंटरेक्शन भी किया है। और उसमें बहुत हैंड्स ऑन एक्टिविटी भी है, डेमोन्स्ट्रेशंस भी है, मैथमेटिक्स भी एक्टिविटी है, वो आप देख सकते हैं। तो अभी चलिए आज के एपिसोड के तरफ। टुडे वी आर वेरी वेरी लकी, हमें यम प्रकाश जी मिले हैं, और उसने बोला कि चलो बच्चों के साथ बात करना है तो मेरे पास टाइम ही टाइम है, मैं बिल्कुल आता हूँ। थोड़ा यम प्रकाश जी के बारे में मैं बोलता हूँ। उनका जो स्कूलिंग हुआ है वो नासिक में हुआ है, महाराष्ट्र में। और ये स्कूल बिल्कुल अपना म्यूनिसिपल स्कूल है, मतलब बिल्कुल जो एक सादा सा स्कूल है। उसने उस स्कूल से उसकी शुरुआत हुई एजुकेशन की। बाद में उसने जो किया है इंटरमीडिएट वो किया है फर्ग्यूसन कॉलेज में, और उसके बाद IIT कानपुर से उसने MSc किया है। और ये तो एजुकेशन हो गया, लेकिन उसका जो प्रोफेशन है वो क्या एक्सलेंट है। अब थोड़ा मैं आपको पढ़ के दिखाता हूँ। इनिशियली ही टॉट अबाउट 10 years एट फर्ग्यूसन कॉलेज, देन ही कंडक्टेड मैथ ओलंपियाड ट्रेनिंग फॉर द डिकेड्स। देखिए मैथमेटिक्स ओलंपियाड के जो ट्रेनिंग होते हैं उसका जो ट्रेनिंग का जो काम है वो प्रकाश सर ने किया है। एंड हिज 38 स्टूडेंट्स ओन द मेडल्स इन द इंटरनेशनल मैथ ओलंपियाड्स। देखिए 38 स्टूडेंट्स, जिसने मतलब इस बच्चों को प्रकाश जी ने नर्चर किया है। एडिशनली हिज सेवरल स्टूडेंट्स ओन मेडल्स इन इंटरनेशनल फिजिक्स एंड एस्ट्रोनॉमी ओलंपियाड्स एज वेल। देखिए मतलब एक का असर दूसरे जगह पे कैसा होता है। इन द लास्ट 30 years he has successfully nurtured many students from the पुणे। और आज नॉट ओनली पुणे, पूरे महाराष्ट्र के जो हमारे बच्चे हैं, जो हमारे टीचर हैं, पूरे देश के जो हमारे बच्चे हैं, टीचर हैं, उनके साथ प्रकाश जी इंटरेक्शन करने वाले हैं। और मैं आपको जो लास्ट में मैं सब आपको बिल्कुल थैंक यू बोलता हूँ। जितने भी हमारे व्यूवर्स हैं, बच्चे हैं, टीचर्स हैं, हमारे पेरेंट्स हैं, सभी को बिल्कुल धन्यवाद या सभी को थैंक यू बोलता हूँ। और हमारी जो आउटरीच की टीम है, देखिए दिस इज अ वेरी वेरी लॉन्ग जर्नी, 50 एपिसोड्स, 2 साल बिल्कुल, और कुछ भी उसमें ये नहीं, गैप नहीं है, कंटिन्यू 2 साल ये पेंडेमिक के पीरियड में हम आपके साथ जुड़े हैं, क्योंकि हमारे बच्चों तक साइंस एंड मैथमेटिक्स की कुछ जो आइडिया है उसका मतलब प्रसार करने के लिए हम आपके साथ जुड़े हैं। और ये जर्नी में पूरा जो हमारा आउटरीच टीम है, मैं उसका भी थैंक यू बोलता हूँ। आइसर पुणे का तो थैंक यू बोलना ही चाहिए, क्योंकि दिस इज हैपनिंग फ्रॉम द आइसर पुणे ओनली, क्योंकि आइसर पुणे ने बच्चों के लिए, टीचर के लिए यह बहुत अच्छा एक फैसिलिटी बना है कि यहाँ बच्चे आकर, टीचर आकर साइंस और मैथमेटिक्स का ब्यूटी जो है वो इंजॉय कर सकते हैं, और उसके जो कॉन्सेप्ट होते हैं साइंस एंड मैथमेटिक्स के थ्रू हैंड्स ऑन एक्टिविटीज से लर्न कर सकते हैं। ऑल्सो लेट मी थैंक यू फॉर साइंस मीडिया सेंटर, जो हमारा साइंस मीडिया सेंटर है, तो उनकी जो टीम है, कि जो ये सभी काम करने के लिए वी नीड लॉट ऑफ टेक्नोलॉजी का सपोर्ट। तो मैं साइंस मीडिया सेंटर का भी थैंक यू बोलता हूँ, फिर और एक बार सभी का थैंक यू बोलता हूँ। नाउ आई एम रिक्वेस्टिंग एम प्रकाश, प्लीज स्टार्ट योर सेशन नाउ। इट्स ओवर टू यू सर।
Hello everyone, it's my great pleasure to be here. Reason being, I have been given a topic, enjoying mathematics in schools. I myself really love mathematics. Over the last 4 decades, I have been spending my time with young kids, age group from 8th standard to 12th standard. I'm told there could be some 5th, 6th standard student also here, so much better. Enjoying mathematics, is my topic, and let me talk about enjoyment first. Let us have a thought experiment. There are 8th standard students, they play basketball. I hope all of you have seen some basketball matches, and these students are having a tournament and they are pitched against 2nd standard student for playing that basketball match. Can you imagine what will happen? Those tiny 2nd standard students, these 8th standard students will easily block their balls, and 2nd standard students may not be able to do even a single goal, and in whatever prescribed time, 8th standard student could win 40-0. If these 8th standard students play these several matches, are they going to enjoy? Will there be enjoyment? Whereas in the second thought experiment, suppose these 8th standard students are made to play a match against 10th standard students. They are stronger than them, they are little taller than them, and if there will be motivation for the students, they know mostly they are going to lose, but the way they will put great fight against these 10th standard students, and eventually at the end, even if they lose 2016, 2018, do you think they will enjoy the match against 2nd standard students, or will they enjoy the match against the 10th standard student, and on a lucky day they may even defeat them? By playing several matches with the 2nd standard student, will their ability to play basketball, will it improve? Whereas if they play a match against the 10th standard student, what do you think is going to happen? Their ability to increase their play better basketball will become better and better. So enjoyment, winning does not mean enjoyment. Even a defeat, when you get a chance to put your best and really give a scare to your seniors that you may defeat them on your day, that is where the enjoyment could be. When there is a challenge in the task, enjoyment is there. When there is no challenge, enjoyment is not there, is one important thing I want to bring to your notice. Now, let us start going to mathematics, because that is what I want to show, that there can be huge enjoyment in mathematics. Let us look at a scenario where 5th standard class is going on, and a teacher comes to the class, writes several numbers on the board, natural numbers, 28, 35, 51, and so on. He asks the students that you have already studied odd and even, do you know how to recognize them? Some of the students may make mistake, but he will make it sure that everybody has understood what is an even number, what is an odd number, and once this is clarified, he will give some exercises to the student. He will say, friends, let us compute this 31 plus 74, 77. This is one example. He say, what is this number? Odd. What is second number? Odd. Please add them. He will say, let us take 53 plus 81. And such 4 or 5 examples the teacher will write on the board. The students compute it. He will ask the student, what is the answer of this? 7 plus 1 is 8, 7 plus 3 is 10, 3 plus 1 is 4, 8 plus 5 is 13, and so on. So what will happen? Students will say yes, odd plus odd is even. They'll do one more problem, odd plus odd is even. 3, 4, 5 more problems, odd plus odd is even. The teacher will ask them, students, what have you learned today? They'll say, yes, we have studied odd plus odd is even. Now, at this stage, if I am the teacher of the class, I'll ask them, see, we have 40 students in the class. I have given a homework and I'm going to test whether all the students have done the homework or not. If I correct the homework of 10 students and say all the remaining students have done the homework, will I be making a correct statement or the wrong statement? What do you think? It is very clear that, all right, these 10 students I have checked, they have completed the homework, but the remaining 30 students guarantee cannot be given. If I check for 20 students and they have all done the homework, can I give the guarantee that remaining 20 students have done the homework? Again, the students would tell me, no, that is not necessary. Then I'll say I have corrected the homework of 39 students out of 40. Each one of them have done the homework. Can I conclude the remaining 40 student has also done the homework? They'll say, no, sir. It is because it seems to be a good class, it is possible that he has done the homework, but guarantee cannot be given. Guarantee, please underline this important one, guarantee. Then I'll tell them, see, the teacher had written some 5 pairs of numbers. On this board, I have written only 2, but teacher may write few more. How many natural numbers are there? These students will say there are uncountable. You cannot count them. They on and on, unlimited, infinite, different language they will use depending upon their expertise. They may not know the word infinite, but they will say unlimited. How many pairs of natural numbers will be there? They will also say unlimited. Among these, how many are odd numbers? They are unlimited. How many pairs of odd numbers will be there? Also unlimited. Among these many unlimited pairs, we have tested few. On my board here, I have tested 2. In a class, they may test 5, 10. But after having done that, you are not allowing me to conclude that I have tested the homework of 39 students and the 40 students have done homework. You are not allowing me to do that. How come you have accepted that odd plus odd is even? It's a big question. So, odd plus odd is even is a correct statement. It could be called information, it could be called a theorem, but if I really want to actually find out any odd natural number and other odd natural number actually becomes even, will I be actually physically able to do it? The way in a small classroom of 40 students, it will take little longer time, but eventually I can complete the checking of each and every student and guarantee that all students have done homework. But here there are infinitely many unlimited pairs of natural number, and even if I keep on doing it on and on and on, I will never be able to cross-check, guarantee that odd plus odd is even. In spite of that, do you all who have studied mathematics, some of you are in 8, 9, 10, is odd plus odd even? Have you written a proof of odd plus odd is even? The mathematics is not about information. Once you ask this question that there are infinitely many pairs and I cannot check each and every pair, in spite of that I have a guarantee that odd plus odd is even, that is where mathematics begins. Knowing the information you cannot enjoy it, but decoding the logic why odd plus odd is even, the joy starts coming in. And generally in my classroom, when I ask these students different methods of finding out, you construct a proof why is odd plus odd even, and time and again it is found students do come up with wonderful ideas. In today's lecture I cannot keep on telling you how different methods the students come out with, but then after some time one of the methods is some of those who are little elder, that is suppose 8, 9 standard among you who are listening to me, they say a natural number is odd number is, when I multiply by 2 it won't be a multiple of 2, 2a plus 1 and 2b plus 1, you add etc., 2 is common. That is one proof they could give. 2a plus 1, 2b plus 1, then 1 plus 1 becomes 2 and so on. But suppose I tell them, I want to teach this concept to a farmer who does not know even how to write numbers and so on. But can I explain the concept of natural number to a farmer? So there are a lot of mangoes the farmer has. I want to tell him whether these are odd, the total amount is what we call is odd natural mangoes are there or even mangoes are there. So then student comes up with a beautiful idea that you start asking to make pairs of 2 mangoes, 2 mangoes, 2 mangoes. At the end, if all mangoes are exhausted and all pairs of 2 are formed, then the total number of mangoes are even. But if 1 mango is left behind, then the total number of mangoes are here odd. So pairing concept gives you, without really knowing numerals, decimal system of numbers, odd is a very simple concept, pairing. You pair. If perfect pairing happens, it is an even number, and if 1 odd mango is left behind, it is an odd number. Then odd plus odd. So there is a pile of mangoes which is having odd mangoes, other pile of mangoes having odd mangoes, you have to add. What will happen now? Those who have already gone through this process, they know, they can imagine that the first group collection of mangoes, because it is odd, when you pair them 2, 2, 2, 1 mangoes are left behind. In the second group also, you will have 2, 2, 2 and 1 will be left behind. And you want to add them, you want to again pair them. Why do all the work all over again? Already pairing has been done. So those pairing you don't want to play with or tamper. And what is remaining in the first group? 1 mango was left. In the second group, 1 mango was left. Put them together, and now it is a perfect pairing in the total group. And what you have seen is, yes, odd plus odd is even a farmer can understand it. So this is where, when such discussion takes place in the classroom, you will start enjoying it. Whenever you will be given information, you say, thank you, sir, this is a beautiful information. Odd plus odd is certainly seems to be even, but we have done only 5-6 cross-checkings. Or I could ask them, you have taken 2-digit numbers. Have you taken 27 crores, 48 lakh, 431, huge odd number. Another, 2000 crore, 400 lakh, 28,311. Maybe that huge odd number plus odd number may not remain even. How do you know that odd plus odd is even? But once this logic is given, they completely understand and start appreciating that odd plus odd is even. So when information is passed on to you, that is a good beginning. But when you go and ask, why is odd plus odd even, that is where the joy starts trickling in. And in a good class, then you ask, you give some example now. This is 3 multiplied by 7, odd multiplied by odd. Another 5 multiplied by 11, odd multiplied by odd. After some examples, they will come and see that, yes, it is odd plus odd is even. But odd into odd is odd. So if one has not understood it, they will try to remember it and they may forget under pressure in the examination. But if this is understood, why odd plus odd is even, they will never feel scared about it. And when your scare is removed, you start having confidence, and once you start having confidence, you start enjoying those lectures. So good students will tell me, sir, let us think about it now. Why is odd into odd odd? In few examples it is happening, but at this stage they know that we are verifying few small pairs why odd into odd is odd. And if you give enough time to the student, keep on discussing with them, eventually they will be able to give a wonderful logic explaining why odd into odd is odd. So because generally one of the technique which I use in my classes, I show a lot of patience. I don't disclose the answer. Here also, if you already know how to prove odd into odd is odd, well, you are a 1 stage advanced student. But if you have never consciously given a thought why odd into odd is odd, you should start thinking what tool you already have. Odd plus odd is even, that you have already mastered. My hint is, use this tool and little thinking, you will be able to prove that odd into odd is also odd. And then these students, once a proof is given to them, they will stop accepting information from you. They will start demanding what is the logic behind it. And a general belief, why most people find mathematics boring, because they feel mathematics is number crunching. 3-digit number multiplied by another 5-digit number, and even if you forget one carried over, etc., one small mistake and you don't get marks. Mathematics is number crunching is what a general belief is. No. Mathematics is not number crunching. Mathematics is all this logic which I'm trying to tell you, that odd plus odd is even, odd into odd is odd, going and trying to understanding that why such happens, that is mathematics. And number crunching is 5 to 10% part of it. Once you do number crunching, how you interpret it when you see that this odd into odd is odd, 7 3 are 21, 11 5 are 55, that's fine. But we have verified finitely many pair, and my intelligence allows me to predict this result not for 100 pairs, 200 pairs, infinitely many pairs, that I am able to say that odd into odd is always odd. That is where the joy starts coming in. Let me have one more example. Let us move to geometry. And what example do we have? Suppose I have angle here. And once I have this angle here, I want to construct an angle bisector. So, how many of you recall the process of bisecting an angle? I'll wait for a few seconds. Everybody in their minds think how angle is to be bisected. What instrument do you use? You take your compass box, you hold a compass, you have a good pencil in that, and then you take that compass and the steel thing you put here. There is a compass there, and you have a suitable distance and make an arc here, and you make an arc here. While doing this, you don't change the distance is kept the same, and you have these two arcs. Having made these two arcs, what do you do next? Either you may keep the same distance, or you may have some other suitable distance, keep the steel end on this and make an arc here. Now, don't change the distance, keep the steel end here and make another mark here, and you have got a point here. And then you use a straight edge, and using the straight edge, you draw this line. Is this a procedure all of you use in bisecting angle? So, there is an algorithm. Take a compass, put it on the vertex, make arc, don't change the distance, make another arc. Now you can change the distance if you want, make one more arc, don't change the distance now, make another arc, and use a straight edge. The first thing which should hit you, a thinking student, is, oh God, they look almost equal. On my rough sketch also, if you do it with proper instruments, hey, what is happening? I was supposed to bisect an angle. I never use a protractor to measure the original angle. I am not measuring the new angles also, but it looks like that this is actually an angle bisector. A job where angle is to be bisected, that angle measuring instrument which you have in the compass box, you don't even touch, and using compass and straight edge, you are able to get it. So this fact is, once you recognize, you say, God, what is happening? Why is it there? But once this information is given to you, and that information is, you remember and try to use it whenever required, the fun is not going to be there. This is information, or algorithm in modern language of computers. You have been given the information of how to bisect an angle. Step-by-step procedure has been told to you. If you leave it and don't inquire further, then the joy which I say is possible in learning mathematics is not going to come to you. And I pointed out that you are not using the protractor at all, and still you are being told that these are two equal angles. Shouldn't you demand to your teacher, sir, it is beautiful, we are shocked that we are not using the angle measuring instrument. Why is this so? So that is where you are demanding knowledge. Information develops curiosity in you. You are surprised that you have not used the angle measuring instrument. And this wonderful procedure, that without even touching the angle measuring instrument, you are getting angle bisector. Why is it so? So then, what logic is to be done? What is the secret behind it? So it is exactly because you followed a certain algorithm, a certain procedure was used. You had kept the compass here and made arc. You did not change the distance. So this distance is equal to this distance. Let me call this vertex V. The first arc which we made, let us call it point A. Let us call this point B. Then what did I do after that? I maybe changed the distance, and changing the distance I made one arc, and keeping the same distance I made another arc. When I don't change the distance, what has happened? This is equal to this. That is what I have done. So because I have done something very clever, therefore the two angles are going to be equal. But what is the reason now? Now those who have studied triangles, they know that there are congruence tests, and here in this triangle, let us call this point P. So in this triangle above and below, what is happening? These two sides are equal. These two sides are equal, and this is a common side of the two triangles, so of course they are equal. So in these two triangles, what is happening? Side test. Those who are studying in Marathi medium, they may say bazu method of comparing the two triangles are congruent, and therefore the two triangles are congruent. And once two triangles are congruent, what happens is, there is also a method taught to you in the school, that the corresponding parts of the congruence triangle. Here is this side is equal to this side, opposite to that this angle, and opposite to that this angle. These angles must be equal. This knowledge comes to you, and when that knowledge comes to you, suddenly something starts happening in you. I call it pleasure, enjoyment. But information you will forget after some time. And after going home, if you will ask your friends from other schools and say, hey, do you know how to bisect an angle? They'll say yes. But do you know why it is so? You will share if you don't have this extra information, they say, yes, it is taught to me, or maybe I have forgotten. But when you have this knowledge, you may want to share with your friends. And the more you share with your friends, that enjoyment is going to come, and you are going to become better and better in doing mathematics. So I talked about knowledge. Now what happens is, there are these two roads, and in especially Pune city, there are blind lanes. Or what happens is, sometimes a tree is, here. The two roads are meeting, and at the ends of the two roads, let me draw another picture here. The two trees are there, and there is a tree. It is not going to be circular. The trunk of the tree is going to be some irregular shape, and vertex of the angle which I want to bisect is hidden inside. Now what happens? I want to bisect the angle. Am I going to cut the tree? Am I environment friendly? Or I want to cut the tree and just my job is to bisect the angle, so I'll do everything nonsense? No. So this is application. If you have studied geometry in the school days and a procedure was given to you, but that procedure is not applicable because the vertex is hidden inside. In mathematical terms, it is called inaccessible vertex. The vertex is not available, but your starting point, you started with that vertex. So now if that starting point itself is missing, you say, I don't know how to do it. But have you studied enough mathematics? Do you know how to really construct this angle bisector without cutting that tree, which I called application? So all mathematics, these three features are there in all the mathematics. That mathematics is, information will be given. You will have knowledge why that algorithm works, and then there will be practical problems. If you want to apply this knowledge in practical situation, there is an inaccessible tree, or maybe there is a seashore here, and these lines are like that. These lines are going into the sea. You are not going to be able to reach there, and you want to draw the angle bisector. How do you do this? That is called application. Do you want me to share the beautiful proof of this? That vertex is not available. How do I construct this angle bisector? For that, I'll require one important theorem from school geometry. What is that theorem? In a triangle, if you draw the angle bisectors, our procedure is given: this angle bisector, this angle bisector, and this angle bisector. These angle bisectors all meet at a point. Angle bisectors are concurrent, and those who are at least in 9th standard or 10th standard, what is this point known as? It is known as in-center line. So angle bisectors come and meet at a point. That is a known theorem. Can I use this result? Here is my vertex is blocked. I cannot put my compass there. But what I'll do is, I'll draw some arbitrary line. Some line I'll draw. A triangle would have been formed, but this is the not complete triangle, but triangle is formed. This vertex is hidden, but this is not hidden. This is not hidden. Can I construct this angle bisector? Yes, I'll construct this angle bisector. Can I construct this angle bisector? Yes. And where will this point be now? Because of this theorem, this point will also be on the third angle bisector. So now, you may feel at this instant, yes, the job is over. But what do you want to do? You want to join this point to the vertex. But you again remember, oh God, that vertex is still inside the tree. I cannot still do it. So what do I do now? How do I really complete the thing? But then, was there anything special about this line? This line was P1, P2. I could take another line, Q1 and Q2. The triangle is changed, certainly. But this angle, for the first triangle, P1, P2 triangle, this angle is the same. For the second triangle, the angle is still the same. So what I can do is, I can again do the angle bisector here, I can do the angle bisector here, and these two angle bisector meet here. Where will this point also be? It will also on the same angle bisector. Now when 2 points have been constructed, you just take a straight edge and join it. You have never cut the original tree and angle bisector has come alive. So that is what the maths, when you are learning, you are having information. Then you will understand that there is a logic, knowledge, and then there are practical problems and you can overcome the practical problem and you can see the application. When all these phases you go through, if you keep on only remembering, oh, angle bisector is like this, perpendicular bisector do something else, and in the exam you may forget it. But the moment you get the knowledge, your confidence increases and it gives you the inner strength that yes, I have understood why it is there. So that confidence starts creating your liking for the subject. You can see the application, some applications, it increases your liking and enjoyment of mathematics, step by step increases. Some of you may have some questions. You please feel free to write in the chart which is available to you. Let us move on to the next topic, and I want to now talk about simple interest. Generally, in the standard 7, simple interest is discussed. What happens? A person keeps some money called the principal in the bank. He gets interest, R% per annum interest. He keeps it for n years, and after n years, he gets, of course, his capital back and more money. That is the interest. It is such an important thing to know what that interest is. So I is equal to P into R into N upon 100. What is this P? P is the principal. What is R? Rate of interest. It is generally stated in the book PCPA, percent per annum, and N, the number of years. And finally, I, interest that he is going to get if he keeps P principal at a rate of R% per annum for n years, then the interest he gets is this. This is a standard process in the school mathematics. This formula is known to most of you. If you are a Marathi medium student, muddal गुणिले दर गुणिले काळ मुदक भागले 100. English medium मध्ये असाल तर PRN upon 100. Not much difference, just language difference. So what we now ask is, I ask the students, my friend, how many problems are at the end of this chapter? So the student generally look at thing and say, sir, there are 50 problems in this chapter. I said, I don't see 50 problems. He says, sir, see, page 1, page 2, page 3, page 4, there are 50 problems here. I said, oh, let us try to analyze it. Apparently, there seem to be 50 problems, but let us try to look at those problems carefully and let me see if your answer changes. So I make them go through the first problem. So some value of the principal is given, 2,000 rupees, or 8% and N 4 years. You say, okay. This is the problem number 1 is given and all this information is given to you. Then when they start reading second problem, they start, chatting with her. Hey, is it really a different problem? Then I take a pause the student says, sir, actually it is not the second, just numerically it is a different problem, but it is actually the same problem, only numbers have changed. Instead of 2000 interest, it is now 3000. Instead of 8%, they are giving 9%. Instead of 4 years, maybe 3 years. It is actually the same problem. It's numerically different. And I bring it to your notice, all right? In the school, when you have finished 6th standard, you know how to multiply. You know how to divide by 100. So therefore, if numbers are changed, is it really a different problem? They all agree, no, it is not a different problem. So I coach them that type 1. The problem 1 was type 1. You want to calculate I. Second problem is also the same type 1. Third problem is also the same type. First 10 problems, 8 problems are only type 1. When they read the next problem, there is suddenly, a big noise in the class. Sir, yes, there is a second problem in there now. Hey, what is the second problem? They tell us now that actually there is interest is given, rate of interest is given, N is given, how much money should I deposit in the bank so that I will get this much interest. So this is a different problem. This was find I. What is this? Find P. Principal. How much principal should you deposit? And when you scan it, several next problem are find principal. Then after some time, by this time they have become expert. They quickly scan the thing. T2, that murmur is in the class. When they come to the, again there is a noise. Sir, yes, there is a third problem. Instead of calculating the principal, calculate the R. What should be the rate of interest be paid for this much amount principal, this many number of years, and this much interest to be given? So find R. And then, can you guess what will be? Will there be one more problem? Yes, they will say, if you want to have certain interest, this much principal is there at this rate of interest. For how many years should you keep in the bank? So they recognize that there are 4 types of problem. So instead of 50 problems, 40 problems, whatever they were saying in the beginning, now they start saying there are only 4 problems. See the shift that takes place in the student's mind. When he knows that at the time of examination, if I want to revise this chapter, some student may keep on solving each and every problem. A lot of time will be required, but for this student, he is so confident that he has marked different types of problem. He will in 10 minutes, T1, T2, T3, 4, he will revise each and everything. He says, my revision is complete. And once that confidence comes, he is doing something not mechanically. Formula is given, you plug the values and put and compute the number. He's thinking, is it really a different problem? So when you start thinking consciously, the burden, apparently 50 problems, get reduced to 4 problems. And then, after some time, a student who is the best among the lot, one or few students, sir, but actually there is only one problem. What is that? He said that formula we know, and in that formula, 4 variables are there. They may not use a variable. For quantities are there, because that variable word may not be known to a 7th standard student. 9th, 10th standard student may call it a variable. And out of the 4 quantities, 3 quantities are given, and only 1 quantity is to be computed. There is one problem in the entire chapter. Do you see how change is going to take place in the student once he's taken through this process? I strongly encourage you to look at your exercises systematically. Is it a different problem or numerically different problem? Then when you process all these things, you are studying consciously, and when your consciousness is attached to it and not mechanically, you are going to enjoy doing that work much more than doing it mechanically. I talked about concurrency of angle bisectors. Let us look at 3 lines when they are drawn. What generally happens? When lines are drawn, a student will come and draw a line. What are the chances when second student goes to the board blindfold and is asked to draw a line? What are the chances that it will be parallel to this, or will it intersect it? The chances that this line is going to be parallel is very, very small, because suppose he chose the one point. Then through this one point, several lines can be drawn. This. Among this infinitely many lines, only one line is going to be parallel. So that is a very rare event. Parallel lines, when 2 lines are drawn blindfold, they are mostly going to be intersecting. So let us take the situation where two intersecting lines are there. Once these two intersecting lines are there, then let us go to the third line now. How generally a line is there? Either a point is given to us and through which I will draw several lines in whatever direction, or a line is given to me, I'll keep on drawing all lines parallel to this. If this line is given to me, so if it is drawn here, it will form a triangle. If it is drawn here, it will form a triangle. If a line parallel is drawn here, a triangle. Only as one of the lines of infinitely lines will pass through this. So when three lines are drawn, are they going to form a triangle or are they going to be concurrent? That they are concurrent is a very, very, special case. It is probability, that is, if is so low, it can be said its probability of getting three concurrent lines is actually 0. Other thing could have been, if I had taken this point and if I was drawing a line, and let me draw this picture once again. Two lines were already on our plane, and through this line I am drawing this line, this line, this line, this line. Only one line will pass through this, and all other infinitely many lines won't pass through it. So if a point is fixed and I am trying to rotate it, out of this infinitely many lines, only one line will pass through the center. So this is something spatial happening. In the 9th, 10th standard students, there are some important theorems. In a triangle, if the medians are drawn, median from what? Suppose I have a triangle ABC, and in this triangle A, a median. What is a median? You take midpoint M of the BC. Midpoint, let us say D of the BC. You join this segment AD, complete line, median. Draw the second median, third median. When three medians are drawn, what is the experience? Is it three lines? We have already discussed, they form a triangle. But what do these three lines do? They are concurrent. Something spatial is happening. Imagine a student who is a young kid is cricket fan, and what could something special be happening in his life? One day on the ground he is playing, suddenly a car comes and stops. Sachin Tendulkar walks in and he plays with those students on that ground. Will that child ever forget that this is something special had happened? Or somebody is a singer and is practicing, and Lata Mangeshkar walks in and she also gives him some lessons how to do it. So these are special events, rare events. It is rarely going to happen in anybody's life, but if it happens, it is a special event. So when lines are concurrent, it is something special that is happening, is to be recognized. That is where the joy starts coming. It is so rare. Generally, three lines, triangle. Medians are concurrent. And then you draw angle bisector, as we say. They are concurrent. You draw the perpendicular bisector of the sides. They are concurrent. Hey, what is happening here? This triangle is a very, very funny object. Generally, the three lines should be forming a triangle. But here, they are concurrent. Something special is happening. And when something special happens, there is a great bonus also associated with. If Sachin Tendulkar comes and gives you some tips, your batting quality is going to improve. Lata Mangeshkar goes and tells you few tricks about singing and how to hold the mic and how to hold the breath and whatnot. You are going to learn something great that day. So here lines have become concurrent. What some students feel is, oh God, now I have to prove that the three medians are concurrent, three angle bisectors are concurrent, three altitudes are concurrent, perpendicular bisectors are concurrent. How, these mathematics teachers, they keep on boring us by this information, that information. But if the child is brought to this information that it is special thing is happening, and then when you have the medians, you know what is speciality of the medians? You draw this median, there is a midpoint, you draw this median, this is equal to this, and you draw this is equal to this, you draw this median, the medians are concurrent, we said. Already a special thing has happened. And what is the speciality of this point? If you take a triangular sheet of paper and if you hold your finger exactly at that point, that gets balanced. The center of mass of that triangular sheet is there. And when something beautiful has happened already, and it has this significance. Therefore, medians are so much useful in higher mathematics, in engineering. Center of mass is such an important concept. You will require it again and again. If you start respecting it, if you start realizing it is a special event and it has such a great significance, you will start enjoying more. You come to the perpendicular bisectors, angle bisectors. I was talking there. So if you draw these angle bisectors, all right, these angle bisectors are concurrent, and we already used that concurrency theorem to construct an angle bisector where vertex was hidden. What else happens? In a given triangle, you can draw various circles which is inside the triangle. But suppose you have been given the job, you want to find the largest circle sitting inside the triangle. How are you going to locate the largest circle which is going to sit inside the triangle? So this eye comes and helps you. You drop a perpendicular here, drop there, all these three are equal, with this as the center and this as the radius. You draw a circle, and that is the largest circle sitting inside the thing. So a beautiful thing when angle bisectors are concurrent leads to another wonderful result, that if you want to get the largest triangle which can be fitted inside the triangle, how do I draw it? Angle bisector concurrency helps you. And then let us go to the perpendicular bisectors. What happens to the perpendicular bisectors? This is the midpoint. Draw a line perpendicular to it. So this is equal to this perpendicular bisector, a line which is bisecting the segment and is perpendicular to it. Another perpendicular bisector and another perpendicular bisector. They all meet at a point. Again, concurrency. Something big has happened. Something special has happened. Sachin Tendulkar has played cricket with you. What is the speciality of this point? Join this point to all the three vertices. You will notice that this distance, this distance, this distance, generally this point is known as O. OA equal to OB equal to OC. You take a compass, put it at the point O, and adjust the distance equal to OA. You can draw a circle which passes through all three vertices. It is called a circum circle. So a rare event of the three lines which were concurrent, the perpendicular bisectors, Sachin Tendulkar coming to your house and playing cricket with you, these three lines should have formed a triangle. If they have formed a triangle, then where shall we put the center of the circle? But this, because it is such a rare event, but it has this beautiful significance that with O as the center, you can draw a circle and it passes through all the three vertices. So rather than looking at your theorems that I have to remember one concurrency theorem, second concurrency theorem, if you have appreciated that they were rare events and with each event something very, very useful and practical is happening, your respect for geometry and mathematics will increase, and that is where your joy will start flowing in you. I also want to talk about tables. I studied in the municipality school in Nashik, and those days in my early childhood, I did not know what table is, etc. The moment we entered the school, everybody will start reciting the table. They were, of course, in Marathi, be ek be, be dune char, be trik saha. These days 2 1 2, 2 to the 4, etc. Table of 2, 3, 10, 11, 30. And believe me, some of you may not know, we used to recite the table of quarter. It used to be called in Marathi pav. Pav is 1/4. Ek pav, pav, be pav, ardha, teen pav, pav, char pav, ek. We used to recite the table of quarter, half, 3/4 and whatnot. So after having gone to the school for a month or two, I was still a very young kid, first standard, but when you recite everything, all those things you know, even now, if you ask me, 29 sate tive don, I don't have to think 29/7 in English language, but because I studied in the Marathi medium, it just comes to me as a single 29 sate tive don. This, my ability to have a complete control on the tables, has helped me in many, many ways. Where does it help me? It helps me that in a competitive exam, these days you know, all these competitive exams, and if you are good at speed. Let us talk about T20 cricket. In the T20 cricket, in the first 10 overs, you are scoring 3 runs per over. Is it a good thing? Or you are supposed to score as many runs as quickly as possible. The time, the speed with which you are able to do is very, very important. And then in this table, if a problem is there, somebody is still counting on the fingers. This is 8 plus 7, 8, 9, 10, 11, 13, 15. That student is going to get into all kinds of trouble. If your tables are good, addition, subtraction is good, you save huge time in the competitive exam, and when your speed is good, you are with the time and the time pressure does not build on you, your mind remains cool, and because your mind is cool, you are able to address the new problems effectively. I strongly recommend that all students, if not about this Pauki Nimki which I talked about, up to the 20, you should really have your tables like that. Instantaneously you should be able to tell 17/7 the what, 5/8 the, up to 10 some people know, but I'm seeing more and more young students of 6, 7, 8 standard, they say, look, start up, 5 on the 5, 5 to the 10, 5, what is happening? 5 to the 40, it has to come instantaneously. Once that speed you acquire in a difficult problem, you will get more time than others to think on that problem, and because you have saved time, you have earned time, your performance in the exam is going to be much, much better. I want you to be very, very good at these tables. Another thing what has happened is there is something method of subtracting two numbers, which is taught these days in the school. 6, 2, 4, 5 minus 3, 6, 9, 2, 9, 8. So this subtraction is done, students do in whatever way. It is taught that this is bigger than that, so you must cancel this 4, right here 3, and this 5 becomes 15, and then 15 minus 8 is 7, and you do this process. Then again, this 9 is there, 3 small, so you cut it, and this becomes 1, this 3 becomes 13, 13 minus 9 is 4, and you keep on doing this. So this method is taught to you, and when it was asked in the exam, when it was taught to you, the teacher wants to cross-check whether you have understood all this method or not, and you must do all these steps and complete the answer. What will answer be here is, this 2 becomes 1, and again 6 is, how much this 1 becomes? It becomes 11. 11 minus 6 is 5, and this 6 has already become 5, and 5 minus 3 is 2. It is a long process. In a competitive exam, in a little bit, slightly okay problem, you may have to do 5, 6 subtraction, and every time you start doing it, you are losing on time. In that exam, when it was taught, it was okay to cross all this and do it. But I strongly recommend that if this problem is there, in that case, without doing all these things, are you able to get that final answer mentally, using everything in the mind? When you will start practicing it, in the first few cases, you may make some small mistakes, but eventually your timing is going to become better and better, and you will be more competitive with the exam. And when it feels so bad, you become sad that actually I knew the subject, I could have done all the problems in the exam, but my speed was bad, and therefore rather than feeling joy after giving the exam, you feel sad. What is the working solution of that? Such things you should do mentally. Do in the mind 4, 3, etc. and get the answer. Once you get that answer, then your time is going to get saved, and it is going to help you in a big way. So tables should be at your command. Your subtraction, multiplication, etc. you should be able to do fast. Is going to save time for you, and time saved is time earned. In the exam, you will be able to spend more time on the logical thinking. Because you are spending more time on the logical thinking, the chances that your answers are more correct will improve, and overall your performance is going to improve. Now, how to attend a lecture? All students from last 2 years, because of pandemic, online lectures were going on, so maybe it is a good thing that is happening that I'm talking about this today, because some student has been attending lecture for last 6, 7, 8 years. He feels that I know how to attend a lecture. But let me give you some couple of important insights into how to attend a lecture. Do you see that a teacher is the same? But among 30, 40 students, somebody does much better, somebody does not do all that well, somebody does very badly. So, isn't it a possibility that this student has an art of attending the same lecture more consciously, more profitably? What is that really he doing? How does he attend that lecture? That is what you need to understand. For this, One important word I want to introduce is anticipate. Do you know one beautiful, famous cricketer, Jonty Rhodes, South Africa, great fielder? He's considered to be the god of fielding. He used to take dives, take catch, stop balls, throw the ball and hit the stump in one shot. Legendary, thing. Do you know the success? What he used to do? He was a great cricketer. He knows who is going to ball. It's outswing or in swing. He knows the batsman, what shots he like to play. And when the ball is being fed, the batsman is adjusting his stance. He knows that this shot is going to come. And anticipating that shot, he used to start moving in that direction already. And the other people will feel that how did he get this, ball in his hand? He had anticipated that shot and therefore his movement had started, and that split second difference, if he had not started, ball would have gone. But when Jonty is there, he used to catch it or stop it. That was the secret of his success, anticipation. Now in this anticipation, what has it to do with attending a lecture? When you attend a lecture, you know something was taught in the last lecture. Then you have to anticipate, what is my teacher going to teach today? Can I take my book and read it on my own little bit and find out that, hey, this is what he's going to teach. Maybe for that, he requires something from previous standard. He goes and revises it, recalls it, understands it properly. He knows this is what teacher is going to teach. And when teachers actually teaches, says the depth of understanding this student will have and some other student will have will be substantially different. So therefore, attending a lecture means anticipating. For that, you have to, after going home, yes, today is my maths lecture. Today is my physics lecture. Today is my chemistry lecture. What I'm talking about, because I'm a maths teacher, I'm talking about mathematics. This is equally true for all subjects. You can use these techniques in each and every subject. So if you go prepared to the class, in that case, you are going to understand much more details as compared to other students. And because you have understood it, the joy is going to increase. But if you go unprepared there and he uses something for the 5th standard, if you are in the 6th class that you have forgotten, then you feel, no, this subject is very difficult. Wrong conclusion, same teacher, but the student goes prepared to the class, anticipation is understood, and you go well prepared, you are going to enjoy these details. I started this discussion with basketball match, higher target. Let me come to that. I had conducted a wonderful program. This program was called Gold 2002. What is this Gold 2002? The way there are Olympic various competitions, football, basketball, various things. There are maths Olympiad, physics Olympiad, informatics Olympiad. So I'll be talking about maths Olympiad. India sends a team, and in this Indian team, only 6 members are allowed to be in the team. That is the maximum size. You can not send any student. If you don't feel your students are good enough, some countries don't send a team. Some countries send only 2 students, but maximum 6 students can be sent. So it is a prestigious matter to be in the Indian team of 6 students, and especially with 138 crore population, it is no joke. So this Gold 2002 was, Pune city had none of the students had won gold medal at International Maths Olympiad. And I used to feel very, very, okay, what as a teacher should I do? How should I do it? I used to ask all these questions to myself. In 1996, the International Maths Olympiad, India was the host country. It was conducted in Mumbai. And I was one of the examiners in that event. And I got a chance to discuss matters with Russian delegates, American delegates, Chinese delegates. Why these 3? Because they are coming in top 1, 2, 3. All other countries are 4, 5, 6 and below. But Russia, China, America, their students are so well prepared, they are there. So I talked to those teachers. I had to take interpreter for talking with Russian and Chinese people. And what they told me was, oh, we used to prepare, it is such a difficult exam, so we used to train our students from 11th and 12th. They say, no, we catch them young. We start teaching them very early. And the best among them, see, you have a problem of finding 6 top students. I have 600 students. Even if I send the last 600 students that merit list, they will still come in the top 3. Several things I had discussed with them, and then it dawned on me that, well, in India, we should start a program much, much earlier. In Bhaskaracharya Pratishthan, which is the center for the state of Olympiad for the state of Maharashtra and Goa, I talked to these people, and we offered a course in 1998. 1996, the IMO was held. I had my other commitment on my hand. I had taken some teaching responsibility. I completed them. And in 1998, we announced that those students who have just finished Standard 7, if they are interested and they want to participate in International Maths Olympiad, represent the country and win a medal, but could I have said bronze 2002 or silver 2002, gold 2002, you are having ambition of winning gold medal at that IMO event, are you ready? You want to really give your best. So several students applied. So I was very happy. I had to conduct an entrance test just for the sake of it, because I didn't have facility to coach all the people. It would have been better if many trained teachers were available those days. So one of thing I really like to talk about is how to train teachers for Olympiad, but that is a separate issue. Now, these students started coming to this lecture. Believe me, up to that, I had taught in Ferguson College, 11, 12, 13, 14, 15, Pune University, 16, 17. I had never taught to the 8th standard student. So my friends used to ask me, Prakash, how are you going to handle them? I said, I have a lot of enthusiasm. The kids have enthusiasm. We'll make great friends and we'll see what to do about it. So 1st July was our first lecture. All the students came. Then the first thing which I did to them, remember a basketball match, higher, you need challenge. I said, you must bring your 8th standard textbook along with you. That instruction was given to them. Once this instruction was given to them, I said, open 5th chapter from your book. 15 June the school start. By 1st July, no school could have completed the 4 chapters and so on. Has anybody already studied the 5th chapter? They said no. So, I'll give you 15 minutes time. You read as much as you can. So they started in the 5th chapter. If you have any doubt, you could ask me, but as far as possible, try to be on your own. So they read the first page and the second page, back to back 2 pages. They finished in 15 minutes. The student, when I had selected them, had agreed to study 2 hours every day for this program at home. So I said, well, are you astonished that 5th chapter, how many understood it? Everybody said, sir, we understood it. One student, because it was the English medium and he had come from Marathi medium, so that he had some English problem. The moment I told him, said, yes, I understand it. So mathematics was not the problem. English was a problem for a student or 2, but everybody could understand all these things. I said, see, why had you been waiting for somebody to teach you all this mathematics these days? Start studying on your own. They all will say, yes, if we could study 2 pages on one's own, we understood everything. So they were young kids. They said in 15 minutes, we could do 2 pages, in 1 hour, 8 pages, in 2 hours, 16 pages. Sir, from tomorrow, I'll finish 16 pages at home and come here. I said, oh, relax. There will be exercises. Are you going to say factorize x square minus y square, only read it and not solve it? Then say, okay, we understand. 14 pages, they said. I said, no, it's too much. 12 pages, 10 pages, 8 pages, 4 pages. After that, say, no, sir, why are you insulting us? We are sure we will finish 4 pages every day, and so on. And of course, I told them, if you have some doubt, I will always be there when we meet in the next class to explain it. So they all agreed to study 4 pages every day. And then things were going on. I was doing something else in the class. After 10 days, I asked one of the students, hey, come on, how many pages have you finished? 40. Second student, 40. One student, 36. I said, yes. He said, sir, my schedule is evening. I study it in the evening and I will finish it, guaranteed. 36 I will finish. Another student, 60. Everybody starts looking at me, hey, what happened to you, 60? Sir, I have a table tennis tournament. He was a table tennis champ. And next week I'll be busy doing that. And this was so simple, I finished it all. I've solved all the problems and I have no difficulty. Others he told, you can ask me doubts if you have any. What is happening? All these students started reading 4 pages every day, 1st of July, and on 31st of August, June and July, it was a 240 pages book. They had finished all book on their own. With little help here and there, some small derivation, but this is what happened to these students. Instead of playing with basketball with the 2nd standard student, I told them, you're strong. Why are you waiting for teachers to teach you? Why can't you study on your own? These students, 140 students, not 1 or 2 good students. Each and every student had completed it, and after 5-6 days, there used to be competition to come to the class as early as possible, because they'll write on the board, sir, there is a mistake in this prescribed textbook of our Maharashtra board. They say 4 is the square root of 16. Don't they understand that -4 is also a square root of 16? This should be correct. And they will come and write on the board, this is a mistake, and they'll put discovered by some Sachin Tendulkar, his name, he'll write there. So there was such an enthusiasm, and then on 1st September when all the students came and met me, I said, come on, go home. You have finished 8th standard, let us meet next year. Say, oh, so what is happening now? We have only one doubt. We are not going to go home now. I said, what is your problem? In the 9th standard, there is an algebra book and there is a geometry book. All we need the instructions, should we start with geometry first or algebra first? All these students, by end of February, had finished entire school mathematics on their own. I only suggested to them, why don't you try reading it? If they had not been able to do it, of course I was ready to teach them. But with small help here and there, they were able to study and complete those books. And I had told them, if there are exercises, write down each and every solution neatly in a good notebook. Because next year in the 9th standard, your teacher will give you homework. And then if you have to do it again, you will get bored. So you tell the teacher, out of 20 problems, you are given 6 as homework, but has all 20 problems. Teacher happy, student happy, everybody happy. And they had finished entire school mathematics in 8th, 9th, and 10th. I told them, you have come here for winning gold in 2002. So if you finish school mathematics, then only Olympiad word will be allowed to use in this class. That motivation was given to them. And all these 141 students had very successfully done it. And do you know what some of them done it? What happens is, when somebody goes to UK, etc., and takes a big degree in medicine, comes back and writes MBBS Mumbai and then FRCS London. So these students started putting some boards outside their house. Don't get scared of 10th mathematics. Don't try to mug. It is simple. I can explain all the logic to you. Your difficulties will be very satisfactorily solved. And they used to write, studying in standard 8. Students studying in standard 8. Look at their enthusiasm and faith in themselves that they have understood it. All these students, by the time they went to the 9th and 10th, other students, when the exam comes, there is a burden on their head. Hey, maths, will I survive or not? How many marks will I get? But these students had finished maths in 8th standard, so they used to study, of course, the Olympiad, and generally everybody knows in history and geography, last days you have to, information based rather than the logic based. It is there. Unfortunately, in the school, it should also be made logic based as far as possible. But in the current scenario, they used to have so much ample time doing it that all students did exceptionally well in their all further studies. Some of them, at least more than a dozen, are professors in Cambridge, Oxford, Stanford, you name, and they are faculty members in various big universities in the world today. Why did it happen? Because I took a chance. It was my responsibility to teach them all the topics. But if they could do on their own, why we were teaching the students all these days? Those students who can do on their own, we should allow them to do it. They will have a difficulty. When that difficulty is solved, great. That is important thing which I conducted the experiment, and it was thoroughly successful, not for 1 or 2 students, 141 students. And if there are 500, I'm sure a single teacher, I could not have conducted 10 batches there. But if enough teachers were there, all 500 students would have eventually reached there, maybe 1 or 2 months late. Maybe some might have taken 1.5 years to finish it. but the confidence that could have been grown in those students would be phenomenal, and that would make them very, very strong students. There is one important topic I want to talk about. I hear this from more grown-up students, not so much from young. Sir, I have tried it 3 times, this problem. Please tell me the answer. I'm bored. What not? Bore word has become unfortunately popular among younger generation more and more. I remember my school days, we rarely used to get bored. We used to play this, that, solve problems, recite poems, create a song on that poem and whatnot. It used to be a great life those days. Now, I want you to do a thought experiment. A child is still infant, not learn to walk, and that child is trying to walk. How many times does this child try getting up, falls down, again tries and falls down, and after many, I don't know the statistical data, those who are in medicine could possibly enlighten us on that. They may be doing this, again try to walk, one step, fall down, again do something, they see some nice, their ball lying there, they will, on their knees crawl there, but they know it is not a great thing, they want to stand and go there quickly, fall again. 100, 200, 500 times, they fall down but get up again. This ability of the child, he does not have that word, it is not possible for me, I got bored. Now have you heard some child saying, please give me crutches, I am never be able to walk, and so on. Are you all walking? Are you using crutches? Are you running also? This important thing you have to understand, that your attitude should remain like childlike, not childish, but childlike. That enthusiasm, that in their dictionary, I cannot walk, such idea does not exist. You must not ask answer so easily. At most you could ask for a hint, and when you start doing it, your self-respect becomes greater and greater, your ability increases, because when answer is told to you, you remember. And let us talk about memory. When you remember, all these people who are sitting in front here, today is some 7th or 8th April. 14th March, what do you eat for lunch? Does anybody remember? It is a foolish question, of course, why somebody should remember that on 14th March what you ate for lunch. But memory is fickle, it goes away. If your teacher tells you the answer, then burden on your memory increases and increases. But if you discover the answer yourself, you know that I had discovered the answer myself. In the exam crunch time, you won't panic, you will go to the basic, quickly even derive that formula in 30 seconds, 40 seconds, 1 minute, and complete the problem and come out winning. So, remove the word failure. I got bored, I tried it 3 times or 5 times. Keep on doing it till you succeed. Be a childlike is one thing I want you to understand. Other thing I want to talk about is 2 books. One book is Mathematical Circles. It is a book written by Russian people. As compared to any other part of the world, Russia Olympiad culture has been 200 years. International Maths Olympiad started in 1959, last 60-70 years. But this Russian Olympiad book, circle is not the geometric circle we talk about. Circle means a group. Enthusiastic students and teachers used to meet in a club, circles, and they used to discuss beautiful problems in mathematics. So entirely astonishing collection of problems are available in this Mathematical Circles book. I'll ask the organizers to give the name and link. This is the author of the book in our below your YouTube facility, and you should all have a look at this book. There is another book which is a favorite of mine. It is not a mathematics book. It is written by Richard Bach. The name of the book is Jonathan Livingston Seagull. It is a story about a seagull. What does a seagull do? It is a very small book. It is a one sitting you can finish it, because there are so many pictures of seagull flying are there, And all my Gold 2002 students, it was a compulsory textbook for them, and they were supposed to tell me after having read that book how they got motivated. It is a great motivator book. I strongly recommend everybody to read this book, Jonathan Livingston Seagull. So these two books everybody should have. And finally, there is one small thing I want to do. You know, great Indian politician, leader, Lokmanya Tilak. Have you heard about him? You know what slogan he had given those days? Swarajya hamadha janma siddha hakka hai and to me milvenaras. Freedom is my birthright and I'll achieve it. On these lines, what should a maths teacher tell you to do? What kind of oath I would want you to take? Simple interest formula is given to you. If you solve those 50 problems and still you have not derived the formula, then you know when you solve it first 5 times, you start feeling uneasy. 6th time, I'm still using the formula, I don't know where the formula has come from. You solve 20 problems, you feel that it is such a difficult, still I don't know where the formula has come from. After 25 problems when you do it, you believe that it must be a job of great mathematician who can discover such formula, I cannot do it. But if you derive that formula, it hardly takes some time if you know simple unitary method. If 5 pencils cost 15 rupees, 1 pencil will cost how much? You know, unitary method. Using that unitary method, simple interest formula can be derived. Simple interest formula can be derived. So, the oath I want to take is, any formula I use, any angle bisector procedure I use, I will use formula. I'll construct the angle bisector, but I'll demand for proof. I will never accept any formula or procedure without proof. So, shall we all take that oath? That I will never accept any formula or any procedure without proof. If you follow all these things, when you know the proof, the joy starts flowing in you, and various things which I have been saying, if you start inculcating these habits in you, you will start loving mathematics more and more. You will start solving difficulties of your friends. Your performance in the exams will increase, and when you are good at mathematics, believe me, as a science student, there is a great career waiting for you. You may become a mechanical engineer or electronic engineer, or you may become a mathematician like Ramanujan, who knows. But start enjoying mathematics. The more you enjoy, stronger you are going to become. I wish you all the best for your career in the days ahead. Thank you.